Section 4.6, our objective today is I can prove two triangles congruent by first proving two other triangles congruent. So let's look at the type of problem we're going to do. So our given in this problem is that angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And what I want to prove is that segment TU is congruent to segment TW. And here's the picture. Okay, so this is T, this is U, this is V, this is W, and this is point S, and this is angle 1, 2, 3, and 4. All right. So what we want to eventually prove is that this segment is congruent to this segment. That's where we eventually want to get. But right now, we know about this angle and this angle and this angle and that angle. Therefore, we know enough to get this triangle congruent to this triangle. Okay? So if we get those triangles congruent, then those are part of this larger triangle, which if I can get those larger triangles congruent, then I can say that TU is congruent to TW. So that's kind of the idea of what we want to do here. So we're going to start out with our given. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And we know that because it was given. Okay? Then remember what I want to do is I want to prove this triangle congruent to this triangle, because I know that this is congruent to this is congruent to that. So I have two angles, so I need a side. And so by reflexive, I can get that side, SV, congruent to itself. So my next line then is SV, segment SV is congruent to segment SV by reflexive. Okay, so now I have that congruent to itself. And so now I have angle, side, angle. So now I can say triangle USV is congruent to triangle WSV. And I know that by angle, side, angle. Okay, so now I've succeeded in proving the two small triangles congruent. Now I can use parts of the two small triangles to prove the big triangle, which would be triangle TUV, and the other triangle would be TWV, to show those are congruent. Okay, so what parts of the small triangle can we use to show that the big triangle are congruent? Well, this one is congruent to this one. So I can say segment UV is congruent to segment WV, and that is by corresponding parts of congruent triangles are congruent. Then I know angle 3 is congruent to angle 4. So I have a side and I have an angle. And then in the big triangle, the big triangles share this side. So by reflexive property, I can say segment TV is congruent to segment TV. And again, that was by reflexive. Okay, so now I have side, angle, side. So I can say the big triangles are congruent to each other. So now I can say triangle TUV is congruent to triangle TWV. And that was by side, angle, side. Now that the two big triangles are congruent, now I have this congruent to that because of corresponding parts of congruent triangles. So now I can say TU is congruent to TW by corresponding parts of congruent triangles are congruent. And so we've accomplished proving what we wanted to prove. But notice that we had to go about it by first proving one set of triangles congruent and then proving another set of triangles congruent. Right, example 2. Alright, so in this one, our given is that x is the midpoint of segment BD, and segment AC is perpendicular to segment BD. And what I want to prove is that angle ABC is congruent to angle ADC. And here's our picture. Okay, so this is A, B, C, and A, D, and this is point X here. Okay, so in order for angle ABC, which is this angle, to be congruent to angle ADC, this angle, in order for those to be congruent, then triangle ABC has to be congruent to triangle ADC. But in my given, I know X is the midpoint of BD, so I know this is congruent to this. And I know that AC is perpendicular to BD, so I know that this is a right angle. Okay, and so I have enough to show, notice that there's actually 1, 2, 3, 4, 5, 6 triangles in this picture. Okay, so I have enough to show that triangle CBX is congruent to triangle CDX. Okay, so let's prove those congruent first, and then I can show that the parts are congruent. Okay, so number 1, X is midpoint of segment BD, and AC is perpendicular to BD, and we know that because it's given. Okay, well, if X is the midpoint, then we said, okay, then we know that XB, segment XB, is congruent to segment XD. And that is by definition of midpoint. Okay? Then I can say that angle CXB is congruent to angle CXD. Okay, because remember the theorem that we had that if two lines are perpendicular, so this line is perpendicular to this one, then they form congruent adjacent angles, okay? So that is the reason we're going to use. So we can say if two lines are perpendicular, then they form congruent adjacent angles. We could have also said that those angles are 90-degree angles and then therefore they're congruent. So that's another way that we could have gotten there, okay? Then I know I need this congruent. So I can say CX is congruent to CX by reflexive. Okay. Right now I can say that triangle CXB is congruent to triangle CXD by side angle side. Okay. Then if those triangles are congruent, then the parts of those triangles are congruent. So now I can say that segment BC is congruent to segment DC. Okay, so this one is congruent to that one. And I can also say that angle BCA, or let's say BCX, is congruent to angle DCX. And we can say both of those things because of corresponding parts of congruent triangles are congruent. So now I have this congruent to this. Then I can get this congruent to itself. So AC is congruent to AC, and that is again by reflexive property. Okay, now the two triangles must be congruent by side angle side. So I can say triangle ABC is congruent to triangle, let me erase that, ADC by side angle side. And then if the yellow triangle is congruent to the green triangle, then their parts have to be congruent. So therefore, angle ABC has to be congruent to angle ADC. Again, by corresponding parts of congruent triangles are congruent. All right, let's do one more. Okay, so in this one, our given is that segment DB is perpendicular to segment AC, and segment AB is congruent to segment C, that should be CB. And angle 1 is congruent to angle 2. Prove that segment XB is congruent to segment YB. And here's the picture. Okay, so this is A, B, C. This is X, this is Y, and this is D up at the top, and this is angle 1, and this is angle 2. Okay. Step number 1, I'm going to use the first part of my given. Okay, so that's telling me that this is perpendicular to this, and I know that AB is congruent to CD. Okay, so I can say then, because DB is perpendicular to AC, oops, lost my line there, then I know I have congruent adjacent angles. So I can say angle ABD is congruent to angle CBD, because two perpendicular lines form congruent adjacent angles. Okay? So now I have this angle congruent to that angle. And so I have a side and angle, and so then I can get a side of the big triangle by saying that DB is congruent to DB by reflexive property. Okay? So in this case, we're proving the two big triangles congruent first, and then we're going to use parts of the big triangle to prove the smaller triangles congruent. Because notice that XB, which is this, and YB, which is what we want to prove, they are part of the two small triangles in the picture. Okay? So at this point, we have enough to say that triangle ABD is congruent to triangle CBD by side angle side. Okay? Alright, so now we've proved those congruent. Now we want to prove that this little triangle is congruent to this little triangle. Okay? So, in those little triangles, I know that angle A is congruent to angle C. And that is by corresponding parts of congruent triangles. Are congruent. Okay? So now I have this congruent to this. Okay? And I know that angle 1 is congruent to angle 2 from my given. So I have this congruent to that. Okay? Then I have two angles and the non-included side. So now I can say triangle AXB is congruent to triangle CYB by angle side theorem. And so then if those two triangles are congruent, then their parts must be congruent. So therefore, segment XB has to be congruent to segment YB. And again, by corresponding parts of congruent triangles are congruent.